Hello students. So today I would like to explain you about uniform and non-uniform motion. Let's see. It's a basic concept in motion in a straight line chapter. Let me consider uniform motion. Uniform motion. First of all, let me explain the concept, then we'll see what's the definition of this uniform motion. Look at this. A particle of mass m initially moving with a velocity of, let's say, 10 meter per second. Okay, is this velocity constant velocity or variable velocity? We have two types, constant and variable. How to decide whether a given value constant or variable? Let me consider 10. Let's say this is 10 meter per second. If this is a constant number, if it doesn't depends on any other values, then I can say that is constant. Let me consider 10 into t meter per second. Is this constant or variable? It is a variable value because this 10 is depends on t value. As t goes on varies, then this complete values goes on changes. Here 10 meter per second is a constant value, this value is a variable value. That's the difference between constant and variable. Look at this. Is 10x meter per second is also a variable? Yes, it is, because it depends on the value of x. So is this a constant value or variable value? Constant value, because this 10 meter per second doesn't depends on any other variables. Let me consider this object initially moving with a velocity of 10 meter per second. What is the meaning of velocity? General meaning of velocity. Velocity is defined as rate of change of displacement rate dx by dt. Otherwise, change in position with respect to time. What's the value they have given? 10 meter per second. Can I read this is 10 meter per second as 10 meters per second? It means, so here velocity is positive, that means object is displaced by 10 meter for every 1 second. That is the meaning of constant velocity. Try to understand this. So this 10 meter per second, the two positive value indicates that object travels 10 meters for every 1 second. This is the meaning of velocity. So what is the distance traveled by this object in 1 second? Same object in 1 second I am calculating. In 1 second, distance traveled by this object is 10 meter. Is this velocity is changing? No, velocity is still same, 10 meter per second. Try to understand. So if any object is moving with a constant velocity, if it is positive velocity, then object distance increases by 10 meter for every 1 second. Are you getting what I am saying? Now observe this. Object velocity right now also 10 meter per second. In 1 second, how much distance it can travel? Again, how much distance it can travel? Again 10 meters. Try to understand. So it travels 10 meter. Are you getting, students? So if any object is moving with a constant velocity, distance traveled by the object in each second will be constant. There is no any change in the distance traveled for each and every 1 second. That is the definition of uniform motion. What is mean by uniform motion? If any object travels equal distances in equal intervals of times is called as uniform motion. Are you getting what I am saying? So try to understand the difference. So what I am exactly trying to say is, so if velocity is positive, okay, and it is constant, then object covers equal distances in equal intervals of time. Okay, in third second, this is actually second 1 second duration. Okay, mass m, velocity is 10 meter per second. So in one more second, in 1 second, what is the distance traveled by it? 10 meters again. That is the definition of uniform motion. If you are following this, please note down the definition. If object travels equal distances in equal intervals of time, then the object is said to be in uniform motion. Did you understand the difference? So same thing, okay, non-uniform motion will be a little different. Okay, did you understand the, students? Okay, let me explain you about non-uniform motion. I will give you a difference between these two after finishing non-uniform motion. So but the name itself indicates that Object travels unequal distances. Look at this. So non-uniform motion. Let me consider same object, mass m. Initially it is moving with a velocity of 10 meter per second. Are you getting, students? Initially it is moving with a velocity of 10 meter per second. So initial acceleration is 10 meter per second square. Initial acceleration is how much? 10 meter per second square. Look at this. What is the meaning of acceleration? Acceleration is change in velocity with respect to time, right? Can I write this as 10 meter per second for every 1 second? So the meaning of acceleration is change in velocity with respect to time. As acceleration is positive, so its velocity will changes by 10 meter per second for every 1 second. That is the meaning. So after 1 second, what is going to be the velocity of the object? 20 meter per second, because acceleration is given to that object. If acceleration is given, object velocity is increases by magnitude of velocity of the object after 1 second increases by acceleration magnitude. That is the definition. Acceleration is equal to change in velocity by change in time, right? That is equal to 10 meter per second per second. It means velocity of the object increases by 10 meter per second for every 1 second. Are you getting difference? So initial velocity is 10 meter per second. Final velocity is 20 meter per second. If you want me to prove it with the help of equation, I will do that. Acceleration is equal to dv by dt, right? Can I write that is as v2 minus v1 by t2 minus t1. T1 is initial time, t2 is 1 second. After 1 second, acceleration magnitude 10, and it is equal to, I need final velocity, v2 is equal to v1 is 10 meter per second divided by t2 is final time, initial time is 0, then v2 is equal to 20 meter per second. Without knowing these steps, I am answering by the definition of acceleration. What's the actual definition of acceleration? Acceleration is defined as change in velocity by change in time. This acceleration I am writing like 10 meter per second by second. That means velocity changes by 10 meter per second for every 1 second. Okay, so after one more second, what is going to be the velocity of the object? Acceleration is still present, that is 10 meter per second square. Mass m, velocity is going to be now 30 meter per second. Acceleration is still present and it is equal to 10 meter per second square. So if you observe in this case, is this velocity is constant? No, it's not. Each and every second its velocity is going to be increases by magnitude of acceleration. Then what happens to distance traveled by the object? In each 1 second duration, will it be same or different? Definitely a different value. Let me calculate the different value of distance traveled in each second. And we know that if acceleration is constant, for a body, then we can use equations of motion, that is Sn is equal to u plus a by 2 into 2n minus 1. This formula is useful to find out the distance traveled by the object in nth second, right? Now let me calculate distance traveled by the object in each 1 second. First second, second second, third second. Are you getting the difference? In 2 seconds is different, in second is different. Second in the sense this duration, 1 second duration. Look at this. I'll calculate the distance traveled in first second, that is s1 is equal to initial velocity is 10 plus acceleration is 10 by 2 initial in first second, right? So 2 into 1 minus 1. And it is equal to 2 minus 1, 1, 10 by 2, 2. So 10 by 2, 5. So 10 plus 5, 15 meters. So distance traveled by the object in first second is 15 meters. So are you getting, students? Now let me calculate distance traveled by the object in second. Okay, distance traveled by the object in second is going to be, so 10 plus 10 by 2. So in place of n, what should I have to substitute? 2 minus 1. So this is going to be 4 minus 1, 3. 3 into 5, 15. 15 plus 10, 25 meter. So distance traveled by the object in second is going to be 25 meter. Can you guess what is going to be the distance traveled by the object in third second? Any guess? If you observe the difference here, so 15 meter and 25 meter, what is the difference between these two? Is that equal to magnitude of acceleration? Yes, it is. So what is going to be distance traveled by the object in third second? 35 meter. If you want me to prove it, I will prove it. That is S3 is equal to 10. S3 in the sense distance traveled by the object in third second. S3 is equal to 10 plus 10 by 2 into 2 times of 3 minus 1. 2 3s are 6, 6 minus 1, 5, 5 5s are 25, 25 plus 10, 35 meter. Am I getting correct answer? Am I getting correct answer? Try to observe this difference. So this is called as non-uniform motion. Non-uniform motion in the sense object travels, are you getting students? Object travels unequal distances, that is 15 meter, 25 meter, 35 meter in equal intervals of time. Second, third second doesn't means that 2 second, 3 second duration. Try to understand 1 second duration only 1 second duration. Are you getting? So I will give you one more difference here. So if object is moving with initial velocity 10 meter per second and if acceleration is given, that is 10 meter per second square, then object velocity increases by magnitude of acceleration after 1 second. Is it initially it is 10 meter per second, later it is 20 meter per second. So in 1 second, how much it is increased? What is the difference? 10. So that is equal to magnitude of acceleration. Are you getting difference? So again after 1 more second, velocity is going to be increases by magnitude of acceleration. That's the beauty of this non-uniform acceleration. This is the exact this year NEET question. NEET 2022 question. This is what they are asking, that what is the distance traveled by the object in each second. I mean ratio of distance traveled they are asking, that is 15 is to 25 is to 35. If you observe that question, a ball is dropped from a certain height. Okay, are you getting what I am saying? So a ball is dropped from a certain height, then what is going to be the distance traveled by the object in first second? Sorry, they are asking ratio of distance traveled, that is ratio of distance traveled in first second, second second and third second. Okay, try to understand. If any object is dropped, I am writing here. So object is dropped. If object is dropped, what is the initial velocity of the object? U is equal to 0. Acceleration due to gravity, we know that 10 meter per second square. In numericals, if they are given acceleration value, consider this. Otherwise, we must consider 9.8 meter per second square only. So look at this. So acceleration direction downward. How much it is? 10 meter per second square. Initial velocity is 0. Acceleration magnitude is 10 meter per second. Is acceleration is constant? Yes, it is constant. Look at this. You can apply same concept over there. Try to understand. Here initial velocity is 10. After 1 second it is increased by 10. That is magnitude of acceleration. So initial velocity here is 0. After 1 second its velocity increases by magnitude of acceleration, that is 10 meter per second. Are you getting, students? So if I want to calculate distance traveled here, S is equal to ut plus half a t square. U is 0 here, so half a is nothing but 5, t square is 1 square, and it is equal to distance traveled by it 5 in 1 second. Are you getting, students? So after 1 more second, velocity is going to be increases by acceleration magnitude. And what is going to be velocity after 1 more second? 20 meter per second. After 1 more second, 30 meter per second. So observe the distance traveled. If distance traveled by this object in first second is 5, what is distance traveled by the object in second? And it is equal to change in acceleration. So this value 5 is increased by magnitude of acceleration. If you observe here, it will be very clear. So acceleration is constant. Object travels 15 meter in first second. So next magnitude of distance traveled is increased by magnitude of acceleration. So 25 meter and 15 meter difference is 10, and it is equal to magnitude of acceleration. So initially it travels 5 meter, then 15 meter, then 25 meter. So 5 is to 15 is to 25. 1 is to 3 is to 5. Did you understand? So that's if you understand the concept, it is going to be very easy. Is that clear, students? Thank you.